The next curve we want to calculate the length of is a asteroid or hypocycloid, right? It's described by this equation here. If you look at it, it's pretty similar to the equation of a cycle, right? X squared plus y squared equal to a squared, right? Only that this exponent is different from 2. It's actually 2/3. So it would be like x to third plus y to third equal to a to third. All right. If a to third is equal to 4, that means that a is equal to 4 3/2. The square root of 4 is 2, so 2 cubed is 8. So a is 8, right? If you plot this curve here, let's say for radius 8, you would get a circumference like this, where this point here is 8. Okay. If you plot the same curve with 1 here, okay, so we have this plus this equal to 8, right? But the exponent is now 1, you would have this rhombus here. Now, if the exponent is smaller than 1, as in this case, what you have is the curve that is depicted here. And that's why the name of this curve is an asteroid, because it looks like a star, right? Okay, of course, this curve should end at 8. So there's a small plotting problem here. This should continue up to 8, right? But anyway, this is what the curve looks like. Actually, if the exponent is smaller than 1, what you get is always something like this. You get something in the shape that is curved inward, like this one. And actually, if the exponent is larger than 1, you will get something which is perhaps something like this, right? Okay, that would be, well, it's not a circumference. It's something that it's got a shape that is more outward than just a circumference there. Okay. So we're going to calculate the length of this curve by calculating 4 times the length of this bit here. And in order to find what this curve is, all we have to do is to eliminate from this equation here. So we have y to third is equal to 4 minus x to third, which means that y is plus or minus 4 minus x to third 3/2. Okay. Plus or minus corresponds to these two curves, but since we're considering just this one, we can get rid of the sign. So we can just pick the plus sign here. And x, of course, goes from 0 to 8, right? When x is equal to 8, then this is equal to 4, and this is 0, which is exactly this point here. Okay. So then the parameterization that we're going to use depends on x. The parameter is x and goes like this. It's 4 minus x to third 3/2, right? In this interval here. And then we have to calculate what is the derivative of that, right? And the derivative of that is equal to 1 for this. And here we have 3/2. 4 minus x to third to the power 1/2, right? And then multiply by minus 2/3 x to minus 1/3. Okay. Now, if we calculate the length of this vector, let's calculate the length square. So we have 1 squared, that's 1, plus, then this 2/3 and this 3/2 cancel. Okay, the minus is irrelevant because we're squaring, so we have this factor squared, which is x to minus 2/3, and then we have the square of this, which is just 4 minus x to third. Remember, this is just this is always positive within this interval, right? There's no problem with that. And if we simplify this, we have 1 plus 4 divided by x to third, right? This is this by this, and minus this by that, which is equal to 1. So this one cancels. So this is just 4 over x to third. So it's very easy to calculate the length, and it gives you a very simple expression, right? The length is the square root of this, which is 2 over x 1/3. I don't put here an absolute value because in the interval we're dealing with, x is positive, so we don't have to. So as I said, the length of the curve is equal to 4 times the integral of this function in the interval 0 to 8. And the function is this one. Well, as you can see, this is an improper integral, but it should be convergent because this curve here has a length, so has a well-defined length, so this should be finite. And actually it is, because it is an improper integral of the second kind because of this 0 here. The function is divergent at this 0 here, but the exponent with which it diverges is smaller than 1. So this function is integrable, there's no problem. So the integral of this is, well, 2 by 4 is 8, and then the primitive of this is just x to 2/3 multiplied by 3/2. Okay, between 0 and 8. And you can see that when you substitute x by 0, you get 0 here. So there's no problem at 0, right? It's perfectly well convergent. So if we substitute this by 8, what we have is 8 times 3/2, and then 8 substituted here. The cubic root of 8 is 2. 2 squared is 4, so it's multiplied by 4. So what we have here is 8 over 2 is 4. So 4 times 4, well, 4 times 3 is 12, and times 4 is 48. Okay, so 48 is the length of this asteroid, this particular asteroid that we have here, okay, with this particular radius.